Welcome all of you. Myself Harshada Garud completed my PhD work entitled Synthesis and Testing of Functionalized Silica Microparticles for Adsorption of a Pollutant from Water. The defense date and awarded on 29 November 24. PhD thesis outline. We prepared sand-derived particles and polymer-grafted sand-derived particles. From sand-derived particles, we prepared activated and amino-functionalized particles, which is useful for the removal of a cationic and anionic dyes as well as a metal ions, as well as it is useful for the removal of a mixed dyes. On the other hand, polymer-grafted sand-derived particles, which is useful for the removal of anionic dyes as well as metal ions. Foundry sand. Metal foundry produce and reuse 100 million tons of foundry sand annually to facilitate the metal casting process. Foundry sand that is classified as a green sand and a resin sand. When the sand becomes unusable by foundry, it is discarded and resulting in approximately 10 million tons of waste sand per year. Goal of a PhD thesis. Development of a useful and nano microparticles from waste green foundry sand, and there is a transformation into nano or microparticle, and from this we prepared a simple bare nanoadsorbent, functional nanoadsorbent and polymer grafted nanomaterial for various applications. Causes of a water pollution and hazardous pollutant. There are many causes of water pollution as well as there are many hazardous pollutants which affects on plant, animal, human being and environment. The project outline. This PhD work deals with addressing possible solution for a realistic problem faced by a foundry industry causing social and environmental issue. Leveraging technologies to address major social sciences. Importantly, this PhD work addressing sustainable and development goals set by United Nations Organization. Goal number 6, clean water and sanitation. Goal number 9, industry innovation and infrastructure. And goal number 17, partnership for the goals. This chapter is the synthesis of a silicon dioxide based adsorbent derived from waste sand for removal of a cationic and anionic dyes as well as a metal ions, and this work is published in journal Silicon. In this experimental work, mainly 3 steps are involved: ball milling, activation and functionalization. Characterizations. This is FESM analysis, shows the formation of unevenly shaped particles with rough surfaces. Structure of a cationic and anionic dyes. These both figures show the chemical structure of a cationic and anionic dyes used as a model pollutant used in this study. Adsorption of a cationic and anionic dyes. After synthesis and fully characterization, the adsorbent which is useful for the removal of a pollutant from a water. And these both figures show the visible absorption spectra of a cationic and anionic dyes at a different time intervals. Adsorption capacity value and reusability of a adsorbent. This table shows the adsorption capacity value for a model pollutant used for 1 cycle and cumulative for 4 cycles. And these both figures show the reuse of ASPS and AFSPS for cationic and anionic dyes. Adsorption capacity of ASPS for metal ions for 1 cycle and cumulative for 4 cycles. This chapter is the synthesis and testing of polyacrylamide grafted derived from waste sand composite adsorbent for a water purification. This work is published in journal Polymers Advanced Technology. This is the experimental work. This is the scheme for synthesis of polyacrylamide grafted sand particles. Characterization, FESM analysis, adsorption of dyes. This figure shows the visible absorption spectra of anionic dyes used at a different time intervals. Adsorption capacity value for 1 cycle and cumulative for 4 cycles, which is given in this table. This below both figures show the use of a PAGSPS on anionic dyes as well as metal ions. This chapter is the synthesis of a silicon dioxide based functional adsorbent for removal of mixed dyes from water. This research article is submitted. This is the experimental work, chemical structure of cationic and anionic dyes. Adsorption of mixed dyes. This is the adsorption capacity value for 1 cycle and cumulative for 4 cycles, which is given in this table, and this below figure shows the reuse of ASPS and AFSPS on cationic and anionic dyes. Conclusion. Water pollution can cause harm to aquatic ecosystem leading to the loss of biodiversity and damage to sensitive habitats. West Pond Sand derived adsorbent prepared by size reduction followed by functionalization show excellent adsorption efficiency against various type of pollutant, and equilibrium data were well described with the Langmuir model indicating monolayer adsorption, and kinetic data were adequately fitted with the pseudo second order kinetic model predicting chemabsorption as adsorption mechanism, and the reusability of adsorbent was proved, and it is crucial for development of a low cost water purification technology. The potential application for developed in this work can be extended to remove various other dyes ions from water, and these are the publications. Thank you.